So good afternoon, everyone. So I'm going to start the unit number 4. So basically, unit number 4 consists of two chapters: design of cylinders, and second one is design of pressure vessels. So I'm going to start the design of cylinders. So afterwards, we shall see the design of pressure vessels. So basically, uh, cylinder concept is cylinder concept is same like what we use in the day-to-day life. So cylinder is basically it has the uh, inside diameter, outside diameter, and length. So you can see. So this is the cross section of the cylinder: inside diameter, outside diameter, and its thickness and length of the cylinder. So cylinders are classified into two types: thin cylinder and thick cylinder. Thin cylinder, so, so it is a special concept, that is spherical vessel, and second one is the thick cylinder. When we can say cylinder is thin, if di by t is this ratio is greater than 20, di by t is greater than 20, or t is less than di by 20. So this type of cylinders are used for used in low pressure boilers and used as a storage tanks. So wherever the pressure is low, so in that application, so thin cylinders are used. Next, thick cylinder. Thick cylinder, here di by t is less than or equal to 20, or you can say t is greater than di by 20. So this type of cylinders are used in high pressure boilers, hydraulic cylinders, gun barrels, and reactors. So for easy of remembering, so you remember this equation: T is less than di by 20 for thin cylinder. For thick cylinder, di by T is greater than di by 20. So especially these are used for low pressure boilers and storage tanks. So you can say in storage tanks, pressure is low. So wherever the pressure is low, so in that case, thin cylinders are used. Wherever the pressure is high, like high pressure boilers, gun barrels. So you can say gun barrels involves very high pressure because bullets are going to fire through that barrel, and reactors. So these are the applications of thick cylinder, and these are the applications of the thin cylinder. Okay. So next is okay. So everyone have understood about these three types of stresses: circumference stress. So it's very important to understand this. So circumference stress always acts in the circumferential direction of the cylinder. Okay, so that is it is denoted by sigma t. So here you can see that is sigma t. So because of this type of stress, so this type of fractures are going to occur. So that means this type of failures are going to occur in the cylinder. Next is longitudinal stress, so which acts in the longitudinal direction of the cylinder. That means it is parallel to the axis of the cylinder. And third one is the radial stress, or it is compressive in nature. So we just say that radial stress is always it is compressive in nature. So this is caused by design pressure acting through wall thickness neglected. So in case of thin cylinders, so this stress is neglected as the thickness is small. But in case of the thick cylinders, so we consider the radial stress. only in case of the thin cylinder. So we neglect the this stress, radial stress. Pi means it is inside pressure. Sigma T means it is tangential stress. Di means it is inner diameter of cylinder. L means it is length of the cylinder. Sigma L means it is longitudinal stress, and sigma T means it is circumferential or hoop stress or tangential stress. So next is tangential or circumferential or hoop stress in thin cylinders. So we shall see in detail about the different type of stresses and its equations. So here you can see the cross section of the cylinder. So where it is shown that the inside pressure and tangential stress. So here you can see that Pi is inside pressure, so which acts on the wall of the cylinder. So which acts on the wall of the cylinder. Okay. So because of that, so the tangential stress will induce on the cylinder wall in the tangential direction. So again, so small t is used to represent the thickness of the cylinder. देखो इधर कि sigma t equation is given by, so just simple it is loading equation. देखो this equation is given by, so देखो pressure into projected area. So this is very important. Projected area means it is, so when you are going to project this on the wall, आपने हम इसको प्रोजेक्ट किया तो क्या होता है, एक सिलेंडर को एक ड्राइंग करने के टाइम पे फ्रंट व्यू टॉप व्यू साइड व्यू में, तो दिस विल बिकम अ रेक्टेंगल. तो इसलिए इसका एरिया क्या हो जाता है, पी आई इंटू प्रोजेक्टेड एरिया इज इनसाइड डायमीटर इंटू, दैट इज इनसाइड डायमीटर इंटू लेंथ. तो प्रेशर इनसाइड का जो एरिया है, तो दैट इज डी आई इंटू एल इक्वल टू sigma t into resisting area. Means, so this is applied stress and this is applied force and this is resisting force. So resisting force is given by sigma t into resisting area. Resisting area means how much it is. So it is also the, you can say, so in this side t and this side t. So that's why it has become total area, total thickness is 2t. So 2t into L. So you can see, so here there is one rectangle. So this is L and this is thickness T, and here also thickness T. That means it is 2 times thickness, length is L. That means it is 2t into L. So if we simplify this, so that we will get it as a sigma t is equal to pi into di by 2t. देखो, so pi into di by 2t. So sigma t is equal to pi into di by 2t into eta L. So eta L means क्या है? So it is the called efficiency of longitudinal. It is called the longitudinal joint efficiency. Otherwise, you can also say it as a efficiency of longitudinal joint. So here hoop stress is uniformly distributed throughout the T, means throughout thickness, as the stress is small. As the stress is small, so it is what you can say, it is uniformly distributed, as the it is value is small in case of the thin cylinder. Okay. So this is about the sigma t equation. So this equation is used to find the to calculate tangential stress induced in the cylinder. So next is axial stress or longitudinal stress. This is longitudinal stress. You can say longitudinal stress acts parallel to the axis of the cylinder. Therefore, this is axis of the cylinder. So this stress acts parallel to the axis of the cylinder. So that's why sometimes it is also called the axial stress. If the cylinder is closed, then only this longitudinal stress is going to act. Otherwise, so there will not be any longitudinal stress because there is no resistance for the pressure. If there is no resistance, so there is no stress will be induced. So that means only in closed cylinders, so sigma L will exist. Sigma L will be induced. So in this case, so again Pi into projected area. Therefore, Pi into, if you consider this section, so force Pi is the pressure into area. क्या होता है इधर बेस को, area is project किया तो ये सर्कल होता है, बेस टॉप और बॉटम में क्या होता है, so this is circle. So projected area means it is pi by 4 into di square equal to sigma L into resisting area. Sigma L into resisting area. Resisting area means एक cross section क्या होता है, तो देखो it is the cross section of this, that is T. How we can say, we can write this cross section, that is pi di into T. So otherwise we can also write it as a pi by 4 into outside diameter square minus inside diameter square. तो उसको आपने सिंप्लीफाई किया तो आपको मिल जाता है, you will get the, if you simplify that, you will get pi di into T. So again, if you simplify, you will get sigma L is equal to pi into di by 4 times T. Again, so same equation by adding efficiency. So eta C means it is circumferential joint efficiency. Otherwise, we can say it as a efficiency of a circumferential joint. So here you need to understand that, so sigma L is and sigma T. If you compare the equation of both type of stresses, sigma L and sigma T. Sigma T is Pi into di by 2T into eta L. अगर eta L को हमने, if you consider efficiency in both cases is 100%, then we can neglect this efficiency, means it will become 1. Pi into di by 2T and sigma L is Pi into di by 4T. Means from both equations we can say that sigma T is 2 times sigma L. Means tangential stress in case of the cylinder is 2 times the longitudinal stress. That's why when design of cylinders, so we always use the sigma T, that is tangential stress, as a design stress. So next is radial stress in thin cylinders. So this type of stress, this radial stress is neglected in thin cylinders, but we need to understand what is its meaning and how it is induced. So this is Pi, inside pressure, and di means it is inner diameter. देखो, so whenever there is some liquid or some fluid on this in this cylinder, so because of that, so the stress is induced. So here it is considered as it is subjected to the inside pressure. Cylinder is subject to the inside pressure. So in that case, radial stress at the outer radius is 0. Here, at this point it is 0, and at this point it is equal to inside pressure. So minus sign indicates that the P is compressive in nature, means opposite to the applied pressure. So that's why the radial stress at the inner point is taken as minus Pi. At the outer point it is 0 when cylinder is subjected to the only inside pressure. If it is subjected to the outside pressure, so at that time, so it is different. Outer radius it is 0, inner radius it is equal to inside pressure. So next minus sign is taken So to indicate that sigma T is compressive in nature. So in case of the thin cylinders, so Pi is very less and sigma R is neglected. Agar Pi is very less means automatically sigma R is also very less. So that's why. So this type of stress is neglected in case of the thin cylinders. So this is assumption that radial stress is neglected as P is small, P is very small.
आणि पाठीसाहेब जवळ मधला एवढा चालायचं आता कसं स्वतः डायरेक्ट मग आपण ओझं पडत नाही ना जोपर्यंत बडी राहतो तोपर्यंत गेलं कामावर नाही गेलं काही तेच घेत नाही तिकडे नसता.
Okay, so this radial stress is neglected as the P is very small. So we are going to neglect the radial stress in case of the thin cylinder. So this is about the three type of stresses. So that will be induced in the cylinders. Tangential stress. So equation is given by sigma T is equal to PD by 2T, Pi into Di by 2T. Next, longitudinal stress, Pi into Di by 4T, and radial stress equation. So here, so this value is taken as 0 in case of the thin cylinders. Principal stresses in thin cylinders. So as I told that there are only two type of stresses. So that is thin in case of thin cylinders, sigma T and sigma L. That is tangential stress and longitudinal stress. Sigma T, sigma L, and sigma R. So sigma T is greater than sigma L, and sigma L is greater than sigma R. So as the sigma T is greater than sigma L, thickness is means thickness is calculated using tangential stress. Thickness calculation of thickness means what it is? It is indirectly its meaning is design of a cylinder. So design of a cylinder is based on the tangential stress. So in case of design of cylinders means whenever we want to calculate the thickness of the cylinder, so sigma T should be equal to the allowable stress. This should be criteria that is based on the failure scale. That means whatever the allowable stress, so that we have to take, it should be equal to the sigma T, because sigma T is always more than the sigma L. That is sigma T is 2 times the sigma L. So normally we need to understand theory on stresses in spherical vessel. So normally problems will not come in the exam. So just I'm going to explain about some brief concept about this. Because so this is a pressure vessel. So its concepts are also same. So you can see that Pi into projected area. Pi into projected area. So if you project this area, so that it will be again, it is a circle. Here को अपने project किया तो आपको क्या मिल जाता है? Circle. That is inside diameter जो रहता है. So Pi into 5/4 into Di square. So इसका जो inside का जो होता है, so project किया तो this will be area is equal to sigma T. So tangential stress is given by, देखो इसको project किया तो you will get this type of area inside diameter and outside diameter. That is sigma into 5 Di into T. Okay, so again if you simplify this, so you will get the Pi into Di by 4 times T. So spherical pressure vessel has twice the strength of the cylindrical pressure vessel. Why? So here there is no sigma L. So there is only sigma T. That means sigma T and sigma L both are equal. For a given inside pressure, so stress induced is by 40. Means it is half of the sigma T as in case of cylinders. So that means the spherical pressure vessels has the twice the strength of the cylindrical pressure vessels. For same pressure, stress induced is half of the cylinders. इसलिए हम क्या बोल सकते हैं? So what we can say? So strength of the spherical pressure vessel has the twice the strength of cylindrical pressure vessel. Okay. So tomorrow, so I'm going to start the problems on the thin cylinder. So I think this time is completing now. So if you have any questions regarding this, so you can ask. So I will give you 5 minutes for the question and answers. तो अगर किसी को कुछ डाउट्स है तो यू कैन आस्क. किसी को डाउट्स है?
नो सर.
तो मेरा आवाज आता है ना क्लियरली?
हाँ सर आता है.
ओके. तो किसी को डाउट्स है? So regarding this, whatever we have covered today, so whatever we have covered today, so this is very important because so this involves all the involves is basic concepts. So what type of stresses, what are types of cylinders? Okay. So if you have not understood this properly, so then we cannot solve the problem more properly. That's why so we need to understand basic concepts in the problem. So next, Sahil, any doubt?
No, sir.
No. Kaushik? Kaushik, any doubt? Ravindra?
No, sir.
No, sir. Okay.
No.
So I think time is completing now, so I'm going to sign off now. So next lecture, so I'm going to explain you the problems on this whatever topic we have covered. Okay. So bye. See
Okay.
you in the next lecture.
Okay.